All right, let's just jump right in. Have you ever looked up at the night sky and just felt that sense of awe, that wonder? Well, what if I told you that you could turn your own backyard into a gateway to the cosmos? And I'm not just talking about looking at stuff. I mean contributing to real science. And you don't need a PhD or a billionaire's budget to do it. That's exactly what we're going to map out today.
And really, that's the whole idea right there. The universe, it's not off limits anymore. This quote just nails the shift that's happening. Technology, data, it's all come together to make it possible for anyone with a little passion, a little curiosity, to become a genuine contributor to how we understand everything out there. I mean, just stop and think about that for a second. The moment you set up even the simplest piece of equipment to look at the stars, you're not just starting some new hobby. No, you're stepping into this incredible tradition of explorers. You're joining a line that goes all the way back to people who looked up, asked questions, and literally changed the world. It's a really powerful legacy to be a part of.
Okay, so the big question, how do we get started? Well, think of this right here as your blueprint. We're going to break down step by step exactly how to take that spark of curiosity and turn it into a real structured scientific pursuit.
And first, we've got to reframe what we're even building here. This is so much more than just sticking a telescope on a tripod. The goal really is to create your own personal laboratory, a dedicated space where you can observe and study the very origins of our universe. It's a serious thing for sure, but man, is it incredibly rewarding. All right, but before we even think about buying any gear, we gotta talk philosophy. Yeah, philosophy. Because the people who are really successful at this, they understand that an observatory is a complete system. It's not just some fancy tool you can buy off a shelf.
And that system, it's built on 3 pillars. Think of it like a 3-legged stool. First, you've got the site. That's your backyard, your specific spot on the planet, and the quality of the sky right above you. Second, the optics. That's your telescope, your camera, whatever you're using to gather that ancient starlight. And third, the data. This is the good stuff, the actual observations you make and how you can share them with the scientific community. You get those 3 things working together in harmony, you're golden.
Okay, here's a key piece of jargon you're going to want to know. It's the word seeing. Now, this has nothing to do with whether it's cloudy or clear. Seeing is all about how stable the atmosphere is above you. You know how stars twinkle? That's bad seeing. A night with good seeing means the air is calm, the stars are steady points of light, and you can get these incredibly sharp views of planets and deep space objects. Honestly, it's often way more important than just having a cloudless sky. So what's the point of all this setup? It boils down to one thing: creating a ready-to-observe environment. The whole goal is to remove the friction. You want to get rid of every little hassle that stands between you thinking about looking at the stars and you actually looking at the stars. Because let's be real, if you can be outside and observing in just a few minutes, you're going to do it way more often than if it's a 1-hour setup ordeal every single time. Okay, now we're getting to the heart of it. And the best part, there is an entry point for absolutely everyone, no matter what your budget looks like. So let's dive in and look at 3 different paths you can take on this cosmic journey. So, take a look at this chart and see where you fit in. First up, we've got the Explorer. We're talking $0 to maybe $200. All you need is a good pair of 10 by 50 binoculars. And with just that, you can start contributing real data, like meteor counts for the International Meteor Organization. How cool is that? Or maybe you're the researcher. Here the budget's a bit higher, say $500 to $2,000. Now you're getting into a serious telescope, like an 8-inch Dobsonian or a refractor on what's called a German equatorial mount, or a GEM. That's a special mount that tracks the stars perfectly as the Earth turns. With this setup, you can hunt for things like lunar impacts or watch planets transit in front of stars. And then there's the astrophysicist. For $5,000 and up, you're building a fully automated station. We're talking a cooled CMOS camera, a big Schmidt-Cassegrain telescope, or SCT, the whole shebang. And what can you do with that? You can hunt for exoplanets. You can measure the brightness of variable stars for the AAVSO. That's the American Association of Variable Star Observers. And get this, professionals rely on the AAVSO's massive database, which goes back decades, to figure out how stars live and die. Your data could literally end up in a breakthrough scientific paper.
So, you've probably got a path in mind now, right? Okay, so let's talk about how we actually build this thing. How do we turn these ideas into a real functional station? Don't worry, we're going to break it down into a simple, actionable process.
Really, it all comes down to just 3 main steps. Step 1, you've got to assess your light pollution. You need to know your sky. Step 2, build a solid foundation for your gear.
Trust me, vibration is the #1 enemy of sharp images. And step 3, integrate all the amazing software that really makes a modern observatory tick.
Okay, so step 1, knowing your sky, is all about managing expectations. Your location pretty much dictates your targets. So if you're in a big city, what's called a Bortle 8 sky, you're going to focus on the bright stuff, the moon, the planets, maybe some cool double stars. But hey, if you're lucky enough to be out in a dark, rural Bortle 2 sky, well, then the faint, wispy nebula and distant galaxies, they become your playground. The important thing is, both of these locations offer fantastic opportunities to do real science.
And this is where the power of modern astronomy just blows my mind. Step 3, the software. This is where the magic really happens. You've got tools like Stellarium, which is basically a planetarium on your computer for planning your night. Then there's NIA, that's nighttime imaging and astronomy, which can completely automate your whole imaging session. And then you have something like Zooniverse, which is a citizen science platform where you can analyze real data from professional telescopes, like the Hubble, right from your couch. And the craziest part? So many of these incredible tools are completely free.
All right, we've covered the what and the how. But now we need to talk about maybe the most important part of all, the why. Why does what you do in your backyard actually matter to the world of science? I mean, really, why?
And I know, it might sound like a crazy question, right? How could your setup, your little observatory, possibly compete with a multi-billion-dollar behemoth like the Hubble or the James Webb Space Telescope? What could you possibly have that they don't?
The answer is actually really simple, but it's also incredibly profound. You have the luxury of time. See, those huge professional telescopes, they are booked solid, every second of every day. Astronomers fight to get just a few minutes or maybe a couple of hours for their projects. But you can point your telescope at the same star, the same patch of sky, night after night, week after week. You provide the continuous, long-term monitoring that the pros simply can't do. And because of that, you become a sentinel, a guardian of the sky. And this is why amateur astronomers are so often the first people to spot incredible cosmic events. We're talking brand new comets discovered from a backyard, supernovae, exploding stars in distant galaxies, unexpected sudden changes in a star's brightness, even things like asteroids hitting the moon. These are the kinds of discoveries being made by the global network of people just like you.
This quote just says it all, doesn't it? You're not just buying a hobby. You're not just an isolated observer. You are commissioning a node. You're becoming a vital part of a planet-wide network of scientific centuries. You are one of the people watching over the sky.
So that really brings us to the final question. The universe is putting on a show for us every single night, and it's just packed with mysteries waiting to be solved. The sky is out there, it's waiting. The only question left is, what will you discover?